In this video, we'll explore the dynamic lights in BabylonJS. We'll cover 4 lights available to us, which include the Hemispheric Light, Directional Light, Point Light, and Spotlight. Each light has unique properties for color, intensity, and range. We'll be going over the use cases for each. Now, lights without shadows look unrealistic, so we'll take a look at implementing shadows with a spotlight as well. This will include casting and receiving shadows on mesh objects, along with ways on improving the quality of the shadows. So let's get started. Alright, so here we are in Visual Studio Code. I've created a class called lightShadows.ts. This is taken from a snippet that I have provided. So it's called lighting_scene_demo.ts in the snippets folder inside of the Babylon examples folder. If you want to follow along with the same code, I will provide a link to the code repository in the description down below. Now, all this starter code has is basic stuff that we need to display a scene. So I have this scene called lighting_scene.gob. This was created inside of Blender, and I want to use this because it has textures, it has different models, and things of that sort, and we can use this with our shadows and our lights that we're going to be going over in this video. So I'll briefly go over what this includes, but before we do that, let's take a look at what this scene looks like. Right now, I do have it running. Okay, so this is what our starting scene looks like. As you can see, we have no lights in here. The only thing that we see are these glowing tubes. We're using a glow layer, which allows us to create this kind of glow effect around the emissive properties of this tube. Now, I am going to be using these in conjunction with some point lights, but you can see everything else is pitch black because we have no lighting whatsoever. We have no environment lighting, and we also have no lights in our current scene. So let's take a look at the code that we have so far, and then we're going to take a look at our first light, which will be the hemispheric light. Okay, so going back into our code, let's take a look at the very top here. At the top of our class, you can see we have 3 new variables. So I am going to be using these in multiple methods. Anytime you want to use something in multiple methods, I do recommend creating a separate variable at the very top. This will allow you to use this basically globally within this class. So the first one we have here is called light tubes. Those are those glowing tubes that we just saw in the scene. And you'll notice that I have an exclamation point right here. Basically, since we're using these in separate methods outside of the constructor, if I were to then remove this, and I'll just save this real quick, if I hover over this, you'll see that it says it has no initializer. That's basically because we're not assigning this in the constructor. So if we're not assigning it in the constructor, we are going to get this error. I'm going to be assigning it down below, but Typescript doesn't know that. So I'm going to add in the exclamation point so that Typescript knows that, hey, I am going to be assigning it. Don't worry, I am going to be assigning it down below in a separate method. Same thing for the models and the ball. Now, the light tubes is an abstract mesh array. I want to reference these 2 tubes, and we're going to be using that with a couple of point lights. So I'm going to be storing both of those meshes in an array. Down below that, I'm doing something very similar for all the other meshes in here. So every model that we have within that scene, I then want to assign to an abstract mesh. Now, the reason why we're assigning this to an array is because for each of these meshes, in order for us to actually use this with a shadow, we need to enable the shadows on each of those meshes. So either to receive or cast those shadows. So once we import the mesh, the entire scene, we're then going to be assigning all those meshes to this models array. Down below that, I also have a single mesh. This is an abstract mesh called ball. This is a basic sphere that we create inside of BabylonJS. And the reason why I'm creating this separately is because this is a basic sphere, which will make it very easy to see the changes in the light properties. So whether we're changing the colors or the specular value or the intensity, the ball is going to make it very easy to be able to visualize that instead of actually looking at the textures and the models that we have in our scene. Okay, we'll jump down to the constructor. All I have in here is the create environment. This is going to be creating the models and the ball that we had up above. In the create scene, you can see that we don't have any kind of meshes that are being created in here. We just have the camera and the scene itself. I did adjust the camera speed down to 0.2, which will make it very easy to navigate around in our scene. Now, in the create environment, I'm using the import mesh async version of the scene loader. And for this, I'm importing the lighting_scene.gob, which I have over here in the public models folder. So lighting_scene.gob. This contains a couple of different meshes that I got from Polyhaven. And I'm importing everything in here, and I'm using destructuring to grab just the meshes. Then I'm assigning the meshes here to the models array. So after assigning the meshes here, I can then use this in any other method as I want. Down below this, I'm also assigning the light tubes. So this is the array from up above. And in this case, I'm using a filter method. The filter method will allow me to specify, I want to look for a specific mesh name. So I'm looking for the mesh name of light tube left and light tube right. So, or either of these, then we're going to assign it to the light tubes. Everything else gets discarded. So we're creating a new array just with these two objects. Down below that, we're creating the ball. And then we create a glow layer. Now, all of this is something that we've covered in previous videos, so I'm not going to go in depth with this. Now, the new thing in here is this method right here, the create gizmos. This is going to help us to better visualize where the lights are in our scene, and we'll see how this works in a moment. But the gizmos are basically the little icons that we see on objects. So if we take a look at Blender, we have different types of icons for moving an object around, rotating it, or scaling it. Well, that's what we can do inside of BabylonJS. We need to use a light gizmo, which is specific to our lights. And then we use the gizmo manager to basically extend out further functionality by providing the position and rotation gizmos. You'll also see one in here called use pointer to attach gizmos. I set that to false. Basically what this means is that if you click on different objects, by default, this will be set to true. If I click on different objects, I can then see that position gizmo or that rotation gizmo on that object. Now, that can be quite frustrating if you start clicking around and you just want to keep the gizmo on your light like I do in my case. So that's why I set this to false. So I don't want to be able to click around on different objects and see that gizmo appear on there. Now, you can play around with this if you want. I'm going to leave it on false. Okay, so with all that said, I'm going to go and save what I have so far. You can see we did get an error down below, so now we cleared that out. Right above the create gizmos, I'm going to create a new method in here called create lights. Now, the first light we're going to take a look at is the hemispheric light. The hemispheric light is something we've covered in previous videos, but now we're going to go a little bit more in depth with it by adjusting the colors of that hemispheric light and show you some examples of how you could use this. So I'll start off by creating a variable called HemiLight. And I'll create a new hemispheric light. We'll provide a name. I'll call it HemiLight. And note we have a vector3, which is a direction. With a hemispheric light, it doesn't matter where you place it in the world. The hemispheric light is going to be our fill lighting. Think of it as the environment lighting. So it doesn't matter where it's at. It's always going to be displaying the same kind of light. The direction does matter though. So whether it's pointing up, down, to the left, to the right, whatever that may be. So we're going to start off with a basic direction of a new vector3. And I want this pointing down. So I'm going to say 0, 1, 0. And it looks like I added in one too many parentheses in there. So let's remove that. There we go. Right, so that's going to be pointing down along the y-axis. Next, we need to add it to the scene. Okay, so we have our basic hemispheric light. I'm not going to be adjusting any properties quite yet, but now we need to call this. Now, I want to create these lights after we create the environment. So in our create environment method, I'll just call this right at the very end here. So I'm going to say this.create lights. Okay, we'll save that. All right, so jumping back into our scene, now we can see everything that's in our scene. We don't have any shadows. Now note, we cannot use shadows with a hemispheric light, but this is a great light to use if you just want kind of fill lighting. Now this is the default value of 1 for the intensity of the light. We can see the specularity on the sphere, but we don't see that on any other objects, right? So the specularity is only going to apply to the standard material. And in this case, the sphere has a standard material. All these other objects in here use a PBR material. All right, so we have everything well lit. We still have the glow layer in effect. All right, let's take a look at how we can adjust the direction and also the colors of the hemispheric light. If we take a look at this sphere, we can clearly see that the light is coming from the top down. We have this nice specular point right here, and down below we have these shadows. So if we were to reverse the direction of that light, the specularity will then be at the bottom and the shadows will be at top. Now, I'm not going to do that quite yet. Let's take a look at the colors of the hemispheric light and why we would want to use this. Okay, so jumping back into the create lights method, what I want to do now is I want to adjust the color of the hemispheric light. Now, with a lot of these lights, we have the same properties, and one of them is the diffuse color. So the way we would adjust the color of the light is by saying HemiLight.diffuse, and it's just diffuse, not diffuse color, just diffuse. And if you hover over this, this is a color 3. So a color 3 is red, green, and blue. So new color 3, and let's say I want this to be red. I'll put in 1 for the red channel, 0 for the green, and 0 for the blue. All right, we'll just save that as is. All right, so now you can see that everything turned red when we change that color. Now, one of the benefits of using a hemispheric light, other than having fill lighting for our environment, is that we can essentially create a horizon. So the diffuse color is our basic color for this light, but we can also provide a ground color. By default, it's going to be this black color, but let's say I wanted to create a sunset. I could have orange at the top and then maybe yellowish at the bottom, or vice versa. I can have two different colors, they kind of mix together. So let's add in a blue color for the ground color of the hemispheric light. All right, so same thing as before. We need to say Hemi Light dot, and we're going to go with ground color this time. This will also be a color 3. And this time I want to set this to a blue color. So I'm going to go 0, 0, and then 1. All right, that'll be blue. Now we have a combination of red and blue. Okay, so there we go. Now we get a nice mix of the red and the blue. So you can see how this can be useful for creating a sunset type of effect. We can also adjust the color of the specular on the sphere. Again, this only applies to standard materials. So let's take a look at how we can adjust that as well. We'll make this green. So to adjust the specular color, say Hemi Light dot specular. That is also a color 3. So I'm just going to copy this up above. And this time I'm going to set this to a green color. So let's make sure that we set these to 0 here. Okay, now if you take a close look at the specular spot here, it is kind of greenish. All right, let's take a look at how we can use this with the gizmo, and then we can play around with the gizmo and adjust the rotation and the position of that light within our scene. So if we take a look at this method, it's called create gizmos. We can pass in a light. This is a generic type. This is the base class for all the lights. So no matter what light we use, we can pass it into the create gizmos. So let's add this in down below. I'm going to say this.create gizmos. And I'm going to pass in the Hemi Light. Okay, I'll save this. And there's our gizmo. So with the light gizmo, all it provides for us is this little icon in the center point. This is the icon for that specific light. The position and the rotation icons that you see here come from the gizmo manager. So if you rotate this, I can then use each one of these axis values here. I can pull on them and I can rotate this. So really all that matters is how we rotate it. It doesn't matter where we place it. So I can place this up in the sky. I can place it on ground. It doesn't matter for a hemispheric light. All that matters is the direction. Now, if you don't see this gizmo appear right away, just refresh the page and it'll appear. Sometimes it takes a few times to refresh to actually visualize that. And you'll see that as we go through this video. All right, so let's take a look at the next light, which is the directional light. The directional light is going to be very similar to the hemispheric light. The main difference being is that we don't have the property of the ground color available to us, and it's directional. So we can actually use this as a sun in our environment. So let's take a look at that. We're just going to briefly go over it because it has almost identical properties to the hemispheric light. So going back into our create lights method, I'm going to take all this right here and I'm just going to comment it out. Now we are going to be replacing this in a moment with the directional light. So let's just create that real quick. I'll call it directional light. And you can see it has nearly identical properties as the hemispheric light. And for the direction, I'm going to set this to 0, -1, and then 0. I'm not going to worry about the colors for this one because it's going to be identical. Again, the ground color is only available to the hemispheric light, but the diffuse and the specular are available on the directional light. Let's pass in the directional light into the create gizmos method this time. Okay, so if I zoom out and I'm using my arrow keys on my keyboard to be able to move around, you can see that I don't see the gizmo on the light, but I do see that the light is actually shining down. So again, if you don't see the gizmos, refresh the page. And there we go. Now I can see the gizmos. Now with the directional light, you will see that the icon is different. The arrows point in the direction of the directional light. I can then rotate this around. And you can see how that works. This is a fairly straightforward light. You'll see that if I move this around, again, it doesn't matter where I place this. It's very, very similar to the hemispheric light. And typically you would use this for like a sun or something of that sort, maybe a very bright source of light in the sky. but there's not really a whole lot to it. So I'm just going to leave that as is for now. Let's take a look at the next few lights. So the next few lights I actually want to include within my environment. The lights we're going to take a look at are the point lights, and we're going to use them with these lights over here, these little glowing tubes. And then we're also going to take a look at the spotlight. And with that, we'll take a look at using shadows. So we're going to remove the directional light. And let's take a look at the point light next. So going back into our code, I'm going to comment this out again. We're going to replace this in a moment with a point light. So with the point light, you can think of this as a ball of light. So this is a great light to use if you want to have light in a specific area in your environment. The orientation of this doesn't really matter. All that matters is the position of this. So let's create our first point light. All right, I'm going to provide a name of point light. And this time we don't have a direction, but we have a position. Again, this is a ball of light, so it doesn't matter how it's rotated. All that matters is where it's located. So I'm going to set this to a new vector 3. And I want to place this in the center point of our world, but I'll set it up to a value of 1 along the y-axis. Let's also pass this into the create gizmos. All right, let's just save it as is, and let's take a look at our scene. Okay, once again, I don't see my gizmo, but I do know that my point light is right in the middle. So it's going to be casting light in every direction. I can see it over here on the pole, I can see it on the barrels, I can see it on the back of the sphere here, and also on the ground. Now, what I want to do is actually use this point light and use it over here. If we take a look at this glowing tube, it does look like it's glowing, but it doesn't actually cast light onto this, which looks a bit odd. So it just looks like a visual effect. It doesn't actually look like it's actually casting light onto nearby objects. So to mimic the effect of this actually glowing and casting light, we can use the point light. We'll set the intensity quite low, and then I want to reposition it where this tube light is at. We're going to do the same thing for the other side as well. So I'll be going over how you can actually duplicate this and use a cloned version of this light. Now, before we take a look at that, I also want to adjust the color. Right now, this color is a bright white. So if I were to then move this over here, and I'll just refresh this so I can actually see the gizmos. Okay, so there it is. I can move this over here. And to move this around, you need to make sure that you click on the arrows. Okay, so there we go. I moved it into position. So now it actually looks like it's casting light, but the light of the point light is actually white. So it looks a bit odd because this looks bright blue and this looks bright white. So I want to adjust the color to better match the glowing tube. And I also want to adjust the intensity so it has a light glow. It doesn't look super bright against this metal piece. Now, we also want to make sure that we move the light into position both over here and also on this side. As you can see, if you probably move this around manually, it is very difficult to get it into position. So there is a better way to do this. What we're going to do is we're going to reference each one of these tube lights, which we've already done in code. And we're then going to say, hey, I want you to move this point light into position of where this tube light is at. And I'll show you how you can do that. Now, before we take a look at that, let's take a look at how we can adjust the color. Now, for this, I'm going to be using a color picker. I found this site online called Online Color Picker. And I'm going to be using this color right here, which is a lighter version of that same kind of bluish color. So if we take a look at the red, green, and blue values here, these values are above 1. So a quick way of using these same values in BabylonJS is to divide this number over 255. So if I say 172 over 255, this will give me a value between 0 and 1, which will work just fine inside of Babylon. So I want 172 for the red, 246 for the green, and 250 for the blue. Now note, if any of these values say 255, you could just use a value of 1 in BabylonJS. It's the same thing. So let's start off with the red, 172. All right, so right below where we created the point light, I'm going to create a color. Now remember, we're using diffuse for the color of the light. Okay, and for the red channel, I believe that was 172, right? But remember, this is not a value between 0 and 1. So how do I get that? Well, I divide by 255. That'll give me a value between 0 and 1 with the same properties of 172 for the red, green, and blue channel. So that's just for the red channel. Let's jump back into our color picker. Let's get the other values. Okay, so green is going to be 246. So 246 over 255, and then 250. All right, so 172 over 255, 246 over 255, and 250 over 255. You could also just divide these manually yourself and provide that value directly in here, but this is a very quick and easy way of doing that. Right, so now we've adjusted the color of the point light. Note that if we did make any kind of changes to the position or rotation of a light using the gizmos in our scene, those changes will not be saved. So if we go back into our scene, this light is going to be at the exact same point as it was before. Okay, so our light is in the center point now. It's a little bit hard to tell, but we should see kind of a bluish hue on the light. Right, so I think the light looks pretty good now. Let's reposition this right where the tube light is at. And we're going to create a clone of this light. Now, the reason why we're going to create a clone of this light is that if I make adjustments to the original object, the original light, I can then have those changes propagate down to any clones that we created of that light. So I'm going to create one light. We're then going to be moving it over here. We're going to adjust the intensity, and then we're going to make a clone of that for the other side. All right, so the first thing that I want to do is I want to adjust the position. Now, if we scroll up a bit, here is where we assign the light tubes. So we assign two objects in here, one for the left side and one for the right side. So now I want to use that object as the parent for each one of these lights. So we're going to start off with this first point light. And the way that we would do this is by saying point light dot parent equals this dot light tubes. And in this case, we can either reference the first one or the second one. It doesn't really matter. So I can say the light tube 0. And now what we're saying here is that the parent of this point light is going to be this light tube at the first element in the array. All right, so let's just save this and let's see if that worked. Okay, so let's take a look at our scene, and you can see that our light did actually get attached. Now, it got attached to the right side, which is perfectly fine. When we create a duplicate of this, we're then going to reference the other light tube. The other thing I want to do is actually adjust the intensity. Obviously, this light is not that bright, so let's reduce it quite a bit. And then we can go ahead and take a look at creating a clone for the other side. Okay, so right before we create the parent, I'm going to add in the intensity property. So point light dot intensity, and we'll set that quite low down to say 0.25. Okay, so now we're going to be creating a clone. Now, the reason why I want to create a clone is because I don't want to have to recreate this entire process for another light that has the exact same properties. So by creating a clone, I can use the exact same properties as before, and then I can make adjustments to say this light, if I want to adjust the color or the intensity, and then those changes will be propagated down to the clone as well. So right after we create all of our properties, then you want to create your clone. You don't want to do it before you actually do all these things down below. So right after we create the intensity, I'll create the clone. I'll leave the parent section at the very bottom after the clone. So the way that we would create a clone is by first creating a variable. So I'm going to call this point clone. And to create a clone, you say point light dot clone. So whatever you're cloning, you first reference that here dot clone. All we need to provide in here is the name. So I'm just going to call it point clone as well. You'll see that we have an option to provide a new parent. I'm not going to be doing that because I'm actually going to be assigning a parent down below like this. All right, so now we need to create a new parent for the point clone. So this will be point clone dot parent equals this dot light tubes, and we're going to reference the second element within that array. Now we are going to get a warning that says this object is possibly null. There are a few ways to get around this. You can either add an exclamation point, but then you're going to get a new warning that says that's forbidden. So one thing to get around this, if you hover over the point clone, you can see it's using it as a nullable light. I want to use this as a point light. So the way I can do that is that after we create the clone here, I could say as point light. Now we're saying I want to create this clone, but I want to create it as a point light. Now, if I hover over this, you can see it says point light. And now that warning went away. All right, so we'll save that, right? We have our 2 point lights, one for the left side and one for the right side. All right, so there we go. Now we can see our point lights are casting light onto nearby objects. Now this actually looks a bit more realistic. Same thing for this side. And there we go. We can see the gizmo on this guy. Okay, now as you can see, that was a bit of a tedious process. If you are going to be repositioning lights like this and attaching them to objects, I would recommend doing this in something like Blender. So Blender can export out point lights, which can be used inside of BabylonJS. So in this case, if I want to create this ahead of time, I can very easily do this in Blender and then export out that light to be used inside of Babylon. But that's how we would attach them in Babylon directly. All right, now let's take a look at how we can use a spotlight. And with the spotlight, we're also going to be introducing shadows. So we're going to create the spotlight. We're going to place it right at the center point, right about right here. And we're going to have it pointing in this direction. Now, a spotlight is typically used for things like a flashlight or something of that sort where you're casting light in a specific direction along a kind of like a cone. So we're going to be using that right here in our scene to cast shadows along these objects that we see off in the distance. So let's go back into our code. I'm going to turn off my point lights and just use the spotlight directly. All right, so I'm going to take all the point light stuff here and I'm just going to comment it out. Now you can leave that turned on if you want, but since I'm recording this, I don't want to have any kind of performance hiccups. So I'm just going to turn off any lights that I'm not using. All right, now we're going to create our spotlight. With the spotlight, we have some new properties available to us. So we provide the position. So again, we can provide a position and a direction in this case. So the position is where we want this located. This will be a new vector 3. And I'll place this at 0 for the x. I'm going to place it at 0.5 for the y, so just slightly above the ground. And then we're going to go with a -3 for the z-axis. So this will be somewhat closer to the camera, but far enough away from other mesh objects. Next, we need to provide a direction. So this is very similar to how we set up the direction for the hemispheric or the directional lights. This will also be a vector 3. We're going to go with a 1 for the y. And then for the z-axis, this is going to allow us to control the rotation of this light. And I'm going to set that to a value of 3. So with the value of 1, this will be slightly above the ground. With the value of 3, this will allow us to kind of rotate it. And you can play around with these values a bit more if you want. Next, we need to provide the angle. So if you think about a cone, the angle is the widest portion of that cone. And when we're talking about angles inside of BabylonJS, most of the time we're going to be using something called math.pi. So we say math.pi. And math.pi is basically 180 degrees. So you would divide that by a number to get a specific degree that you're looking for. If I want this to be 90 degrees, I'll divide that by 2. So I'm going to use math.pi divided by 2. I'll save this real quick, right? So we can have that move down. Next, we need to provide the exponent. Now, the exponent is basically how far out does this light reach before it starts to die off. So think of this as the dissipation of the light. So the exponent, I'm going to set to 10. And then finally, we need to add this to the scene. Pass in the spotlight for the create gizmos. I'll save this. Okay, so we can see that the light is shining light on a sphere, but you can see it's not very bright. We kind of get some hints of it on the barrels here, but it's not very bright. So let's adjust the intensity of this. Okay, right below the spotlight, let's add in the intensity. We'll set that to a value of 10 for now. Save this and give that a quick look. Okay, much better overall. I don't see the gizmo, so I'm going to refresh. There it is. You can see it's kind of pointing up at an angle. That is the z-axis. So if you want this pointing down further down, you then want to adjust the z-axis for that. But for this, I can adjust the position, and it is going to affect the lighting in our scene. Move this in closer. I can rotate this down. Okay, now the process of adding shadows is going to be similar for all the other lights, except for the hemispheric light. The hemispheric light does not support shadows, but for all the other lights, we can use shadows. Now, this is a multi-step process. What's going to happen is that we need to enable shadows on the light here. So this needs to be able to cast shadows. And then we also need to be able to utilize shadows on these objects. So these objects need to receive shadows and cast shadows as well. You can do either or. So if you don't want an object to cast a shadow, you don't have to enable it. Same thing for receiving shadows. Now in my case, I want to receive and cast shadows, and we're going to do that for all the objects in our scene here. That's why I created a separate array for all the models. So let's get through that process now. So for the spotlight, we need to ensure that we can actually utilize shadows with this light. So if you just start typing out shadow, you should see shadow enabled appear. This is a Boolean, so we'll set that to true. Okay, this doesn't do anything by itself. We also need to create something called a shadow generator. So I'm going to call this shadow gen, and I'll set that equal to a new shadow generator. Now the shadow generator you can think of as a big texture that contains all the lights and shadows for our scene. Now we need to provide a map size, which is essentially the resolution of that texture. We can set it to a size of 1024 to start, and we can adjust that higher if need be. Okay, so 1024. And with a shadow generator, this can only be used with one light at a time. So if you have multiple lights in your scene and you want each of those lights to have their own shadows, be able to cast shadows, you need to create a new shadow generator for each one of those lights. We're just using this with a spotlight, so we need to pass that in here. The last parameter in here is optional. I'm not going to provide it, but this will basically help you to improve the shadows. I'll leave that out for now. Okay, again, just with these two things right here, this is not actually doing anything. We're basically just creating the texture, and we're saying, hey, I want to use this light with shadows. Now we need to actually have something cast shadows and receive shadows. So we'll do this very simply with the ball that we have now, and then we'll take a look at using the shadows with the other objects. So if we scroll up to the very top here, remember we had our abstract mesh. We're going to be doing the same thing that we do with the ball with all the models. The difference is that we're using an array for all the models versus a single mesh. So after we create the shadow generator, I'm going to create the shadows for the ball. So we're going to say this.ball. And again, if you type out shadows, you can see that we have receive shadows here. I'll set that to true, so we can receive shadows on the ball now. And I also want to be able to cast shadows. Now, the way that we would cast shadows is by referencing the shadow generator. So we'll say shadow gen dot, and if you type out dot and add, you'll see add shadow caster. So this is pretty self-explanatory. Basically, it allows us to pass in a mesh that we want to use as something that can cast a shadow. And what do I want to cast a shadow with? Well, the ball. So this.ball. Okay, so let's save that real quick and let's take a look at our scene. Now, when you take a look at your scene, it may be a little confusing because you're going, well, I created a property that allows me to receive shadows and cast shadows, but I actually don't see any shadows in here at all. The reason why we don't see any shadows is because even though that the ball can cast shadows, these objects over here have not been set to receive shadows. So we need to actually do this for all the other objects in here as well. So right below where we created the shadows for the ball, now I'm going to be using that models array to loop through the array and then do the same thing that we did right here. So we say this dot models. Again, we're referencing the array from up above. So we're referencing this guy right here. This is going to loop through all the abstract meshes that we have and enable the shadows for receiving and casting. So this dot models dot map. And with map, this will allow us to basically go through each element in that array and then do something with that element. I'm going to say mesh for the element name. And what I want to do here is I want to say for every mesh in the models array, I want to receive shadows, and I also want to add it to the add shadow caster. So let's start off with the receive shadows, mesh.receive shadows, true, and then shadow gen dot add shadow caster, mesh. So every time we loop through an element in here, we're then going to receive shadows and add it to the shadow caster. All right, let's save this and let's take a look at our scene now. Okay, and there we go. Now we can start to see our shadows. So there's the shadow for the sphere. I can see the shadows for the barrel. We can see the ones for the pipes and all that kind of stuff. I'm going to increase the intensity of the spotlight so we can see this a bit more clearly. All right, so right now the intensity of the spotlight is set to 10. Let's bump this up to 100. We'll save this again. Okay, and there we go. Now we can clearly see the areas that are lit up and which parts have shadows. Now, if you take a close look at these shadows, they did look a bit jagged. Let's go back into our code. Let's take a look at how we can play around with filtering of our shadows. So we need to provide a filter for the shadow generator. I'll do this right after we created it. I'll say shadow gen dot and type in use, and you can see all the different filters that we have available to us. Now, not all of these filters can be used for every single light. There are specific filters for different types of lights, and also there are only a few filters that can be used with WebGL 2.0. So keep that in mind. The one we're going to be using is called Use Blur Close Exponential Shadow Map. Quite a mouthful, right? And this is just a Boolean, and I'll set this to true. All right, let's save this again, and let's jump back into our scene. And here we go again. Now, this may be a little confusing once again. So I don't have any shadows after I added that in. Now, the reason why that appears is because when we use this kind of filter, we need to enable a new set of settings for the light. This is the shadow min and max. Okay, so the settings that we need to enable are actually on the light itself. So after we created the spotlight shadow enabled, I'm going to say spotlight dot, and if you type in shadow, you should see shadow max Z and shadow min Z. You can think of this as the clipping planes for the shadows. So basically, how far out do we want to see the shadow, and how close do we need to be an object to actually see the shadow as well? So the min Z, I'll set to a value of 1. And then we'll do the same thing for the other side. Okay, so the minimum and the maximum of that shadow. Again, this refers to the clipping planes of the shadow. Once again, we'll save that. We'll jump back in. And there we go. Now we have our shadows back again. And you should see a little bit of a fuzzy look around the edges of the shadow. Now, there is one last thing we could take a look at in terms of improving the quality of these shadows, and that's by adjusting the resolution of the shadow map. So going back to the shadow generator, we're using 1024 for the resolution. And note, this number is singular. We are using a 1024 by 1024 value for the shadow generator. So whatever number I provide here, we're essentially using that as a square. So we're going to go with a value of 2048, which will double in size. So now this shadow map will be 2048 by 2048. I'll save this once again. And there we go. Now we can see that the shadows do look a little bit cleaner, a little bit crisper. Now you can continue to tweak the shadow quality, but do note that it is going to decrease performance of your scene. So keep that in mind. Whenever we're working with dynamic lights, these can be a bit of a performance hog. So I would keep this to a minimum. Go for something that looks good, but doesn't look too bad. Okay, and here is our final scene. This is with the point lights enabled. You can see that spotlight is casting shadows. And now we have some glowing tubes on the side here. So there you have it. Now there is quite a bit to go over in terms of lights and shadows. This is just covering the dynamic light aspects. When we're working with lights, you always want to think about performance. So in future videos, we'll cover how to use baked lighting, which is going to help with performance and also improve the visual quality of our lit environments.